In this video, we will use a Pythagorean identity to find other trig ratios given one trig ratio. Let's begin with what we already know. We know that when we place a circle in a coordinate plane, we will also have the quadrants. And we assign our quadrants starting from the upper right section of the circle, rotating counterclockwise as you can see in this figure. Let's consider this circle with a radius of 1 unit. And we will call this the unit circle. When studying the unit circle, it was observed that a point on the unit circle is also a vertex of the right triangle that can be formed. And that point can be represented by the coordinates cosine theta, comma sine theta. Keeping in mind that cosine represents the x-coordinate and the y-coordinate is represented by the sine theta. Since the legs of the right triangle in the unit circle have the values of sine theta and cosine theta, the Pythagorean theorem, which is usually what we know, a squared plus b squared equals c squared, and in terms of xyr, which is x squared plus y squared equals r squared, can be used to obtain cosine squared theta plus sine squared theta equals 1, or sine squared theta plus cosine squared theta equals 1. And this is well known as the Pythagorean identity. And this is true for all values of theta in the unit circle. Let's use this Pythagorean identity to find the sine theta given the cosine theta, which is equivalent to negative 3/5. And the theta is located in the third quadrant. So first, we know that the point is somewhere in quadrant 3. And to find the ratio of the sine, which is what we're trying to solve, we will use the Pythagorean identity sine squared theta plus cosine squared theta equals 1. Since what we have is cosine theta, which is negative 3/5, let us just plug in the formula the cosine that is given to solve for the sine. So plugging in, we'll have sine squared theta plus negative 3/5 to the second power equals 1. Since we are solving for sine, to isolate the sine on this side of our equation, we're going to subtract negative 3/5 to the second power on both sides. So we'll have sine squared theta equals 1 minus negative 3/5 to the second power. Let us use our calculator to simplify the right side of our equation. So using our decimal scientific calculator, let's subtract 1 and negative 3/5 to the second power. And in decimal we have 0.64, but we want to keep it as a fraction. So I'm going to click this button right here to convert to fraction, and we'll have 16 over 25. So we will have sine squared theta equals 16 over 25. And because we have that squared, we want to get rid of that too by taking the square root of both sides. And to get rid of that, we can cancel the squared and square root, and taking the square root of 16 and the square root of 25, we'll have sine equals positive negative 4 over 5. Now, the sign of our final answer will be based on the location of the point in our quadrant. So remember, cosine theta is x and the sine theta is y. Therefore, the sign of the y in the third quadrant is going to be negative because you're on the negative y-axis. So our answer is going to be sine theta equals negative 4/5. Now, to summarize what we just learned, we can use the Pythagorean identity, cosine squared theta plus sine squared theta equals 1, to solve for cosine theta from sine theta or vice versa. Also, we learned that the unit circle has a radius of 1, and that any point on the unit circle that makes an angle with the positive x-axis has the following values. Cosine theta is equal to x over 1 or x, and sine theta is equal to y over 1 or the y. Additionally, any point on the circle must satisfy the equation x squared plus y squared equals 1. And therefore, the Pythagorean identity is true, which is the cosine squared theta plus sine squared theta equals 1.